One, just let me know if it is clear. On router number 4, you can see I have added one more command, neighbor 46.1.1.6. This is the IP address of router 6 fast ethernet 0/0, which is connected with router number 4. Now I am going to access R5 and R6. Nirav, do you have any question from last class?
No, sir.
No. Suresh, do you have any question from last class, brother?
No question, sir.
Good. So here on router number 5, I am going to say neighbor 35.1.1.5 and remote AS is 100. So here we have formed eBGP neighbor. What happened? Neighbor, sorry, not 35.1.1.5, 35.1.1.3. Done. And I am going to say there is one more neighbor, that is, let's say, 56.1.1.6 is the IP address of router 6. I'm going to use physical interface IP address because router 5 and router 6 are directly connected with each other. You already know why we are using BGP neighborship, why we are forming BGP neighborship with loopback interface. Whenever routers are indirectly connected, whenever we are configuring indirectly connected BGP neighborship, we should configure through loopback interface. And when we are configuring BGP between two routers that are directly connected with each other, then we can use physical interface IP address as well. Okay, so neighbor 56.1.1.6 and remote AS is 500. Okay, and on router number 6 also I will add this command. And from router number 5, I'm going to remove EIGRP configuration also. Let's say here on router number 5.
Excuse me, sir.
Yes.
Sir, for forming a neighborship with loopback address,
Okay.
we will use multi-hop command now, sir.
Yes.
For external BGP.
Exactly.
But for physical interface, is it not required?
No, it is not required. That is directly connected rule, and that is applicable for eBGP neighbor. Getting my point? Let's say I have 3 router like this. Let me one epic. Let's say I have a router 1 here, router 2 here, and router 3 here. I have connectivity between 1.1.1, which is the loopback of router 1, and between 1.1.1 and 3.3.3. 3.3.3 is loopback on router number 3 and 1.1.1 is loopback on router number 1. Let's say here we have connectivity through OSPF. We are running OSPF routing protocol, and you want to form BGP neighborship between 1.1.1 and 3.3.3. Okay, so if you want to form iBGP neighborship, let's say on router number 1 also you are running BGP 100, and here also you are running BGP 100. So in this scenario, directly connected rule is by default disabled. Getting my point? But if you are configuring 100 on router number 1 and 200 over here, so you are forming eBGP, indirectly connected eBGP neighborship. So in this scenario, you need to disable that feature. Multi-hop, you need to set multi-hop 2 on router number 1 also and on router number 2 also. If you will set multi-hop, automatically the directly connected check rule will also disable. But in case of iBGP, it will send an all message of BGP on what TTL value? 255. Yes or no? In case of eBGP,
Yes,
it will send message of BGP on what TTL value? 1. Getting my point? So in case of iBGP, you don't need to run that command. Okay, and if you are using physical interface, then you can see both are reachable with each other, and we are forming BGP neighborship with directly connected router. So here, if it will send, by the way, the router 6 is their iBGP neighbor, but even if router 6 is their eBGP neighbor, then also we don't need to configure multi-hop command there. Yes or no? Because TTL value 1 is perfect. If router 1 will send any message with TTL value 1, router 6 will process that. Yes or no?
Yes, got it.
Okay.
Thank you, sir.
On router number 6, I'm going to say 46.1.1.4 and remote AS is router BGP 100 and neighbor 46.1.1.4 and remote AS is 100. And there is one more neighbor 56.1.1.5 and remote AS is same 500. Okay, and I am going to say no router EIGRP, no router EIGRP 100 or 10, I think it's 10. So EIGRP neighborship has goes down. Getting notification message over here, I think something is wrong. On router number 4, do show history. I have run what command? Neighbor 35.1.1.5 remote AS is 100, that is perfect. And 35.1.1.5, I need to remove 35.1.1.5 command here. No neighbor 35.1.1.5 and remote AS is 100. I have removed this command and do show history. After that, neighbor 56.1.1.6 and remote AS is 500. So here I don't have any problem. On this router I am going to check do show history. So router BGP 100. So here I need to configure BGP 500, not 100. So no router BGP 100. Here I will configure what router BGP 500. Sorry. And neighbor 46.1.1.6 and remote AS is not 6, it's 4. Again I am doing mistake. And remote AS is 100 and there is one more neighbor that is 56.1.1.5 and remote AS is 500. Soon BGP neighborship will come up with both router. Okay, 56.1.1.5 and there is one neighbor 46.1.1.4 and there is one neighbor 56.1.1.5. okay, now on router number 1, I need to advertise networks as well. So on router number 1 I am going to run network command router BGP 100 and network 10.1.1.0 subnet mask 255.255.255.0, the network 10.1.2.0, 10.1.3.0, 4.0 and 5.0. okay, I am going to advertise 20 networks. So I can do one thing here. I am going to copy the command do show history. I'm going to copy this command and let me paste it in notepad, and here just I am going to change this value to 20.1.1.0 to 20.1.5.0. on router number 2 I am going to paste the command. Okay, now on router number 5, so on router number 5 AS number will become what 500 and 50 network is there 50.1.1.0, 50.1.2.0, 50.1.3.0, 50.1.4.0, 50.1.5.0. let me copy it and let me paste it on R5. okay, and then on router number 6 so this is BGP configuration here. right? I have configured BGP successfully on all routers, right? Now if you will check BGP table of router 1 is receiving this 50 and 60 prefixes from their two neighbor, from router 3 also and from router 4 also. Now tell me, router will install these prefixes 50 and 60 via which router in their routing table?
Router 3.
Why?
We'll check next hop.
So both next hop is reachable. 3.3.3 is also reachable from router number 1 and 4.4.4 is also reachable from router number 1.
The 60 prefixes from 4.4.4 and 50 prefixes from 3.3.3.
Okay, you are saying that it will receive 50 prefixes via router number 3. Okay, let me show you first the BGP table of R1. So IP BGP. By the way, 50 and 60, both network is, it is receiving this network from both neighbor, but from both side you can see next hop is not updated. Because of that, from both side it is only valid, not best. So first of all, I am going to run command next hop self. So if you want to receive these all prefixes via router number 3, let's say, so on only router number 3 you will run that command. This is the first attribute. Next hop should be reachable. Router BGP 100 and then neighbor CCIE is the peer name, and what I am going to say next hop self. I have add this command in this peer group. Now it will install all prefixes via router number 3. So IP BGP via router number 3, 50 also and 60 also. Okay, you can check routing table as well. So IP route BGP. So it have installed all 50 and 60 prefixes via router number 3. Okay, but I am going to run this command next hop self on router number 4 also. Let's say on router number 4 also I am going to add this command. Router BGP 100 and neighbor CCIE and next hop self. Now both next hop is reachable. So now tell me, router will install which path? Okay, so you are saying, someone is saying router 1 will receive 50 prefixes via router number 3 and 60 prefixes via router number 4. Yes or no? So first of all, see the routing BGP table of router 1. So IP BGP. In BGP table, we are able to see the 50 prefix is best via router number 3 and 60 prefix is also best via router number 3. Hello. Why router 1 have installed both 50 and 60 prefixes via router number 3, guys? So IP route BGP, you can see next hop 450 networks and 460 networks is 3.3.3. Why? Oh, I'm expecting guys answer, because in last class we had discussed this, that now router 1 is performing best path selection on the basis of lower neighbor router ID, because till neighbor router ID all attributes are same. All attributes are same. Both next hop are reachable. From both sides it is getting equal weight value, that is 0 0. From both sides it is getting what local preference value? 100. So IP BGP 50 and 60. From 50 and 60 from both sides local preference value is what? 100. From both neighbor. Then it is going to check next attribute self-advertised. So no, it is not self-advertised prefix. It have received from their IBGP neighbor. Then it is going to check what? AS path. So AS path is also what? ES path is 500 in both. When both it is receiving 50 and 60 prefixes from both neighbor, ES path is 500. Getting my point? Why, guys? Why ES path is only 500? Because when router 5 will advertise 50 prefixes to router number 3, it will include ES number, that is 500. When router 3 will advertise it to R1, it is advertising to their IBGP neighbor, so it will not include ES number. So that's why router have installed this prefix through what ES number? 500. In the same way, when router 6 is advertising it is advertising to their eBGP neighbor, so it will include ES number. But when it will send update message to R1, it is updating to their IBGP neighbor, so it will not include ES number. So from both sides, it is getting same ES path. Then it is going to check next attribute, that is origin code. So both are advertised with network command. That's why what origin code here we are able to see. What origin code is
Sir,
there?
but,
Yes.
sir, but the AD value of IBGP is greater than AD value of EBGP, no, sir.
Yes. eBGP have
So,
lower AD value, but both are in
Yes,
say
sir.
in this scenario. See, router 1 is receiving 50 and 60 prefixes from their IBGP neighbor. Router 3 is also their IBGP neighbor, and router 4 is also their IBGP neighbor.
So this means 60 prefixes first reach to router 4, then it will reach to router 3, no, sir?
Yes.
How? Okay.
First, no, brother, it's happening like this. These 60 prefixes, first router 6 will advertise to router 4, and then router 4 is advertising to router 1. Router 4 will advertise to router 1 also, it will advertise to router 2 also, it will advertise to router 3 also, to their all neighbor. But R3 will not advertise those prefixes which R3 have received from their IBGP neighbor. So there is route reflector concept, okay? So R3 will not advertise 60 network to R1. R3 will advertise only 50 prefix. In the same way, R4 will advertise only 60 prefixes to R1, not 50 prefixes, because R4 will receive 50 prefixes from their IBGP neighbor. Getting my point?
Getting, sir, but if we consider AD value, no, sir, this is the best route, no, sir. Why
So AD value over here is what? 200, and AD value over here is what? 200. So AD value is equal, na, brother, from both neighbor.
But here, sir, I am talking about now you are telling that via R3 is the best route, no, sir,
Yes.
for 60 prefixes also.
Yes.
But to reach R3, it should reach via R5 or R4, no, sir.
To reach R3.
Yeah.
Where? From
Which route
where?
it will take? No, 60 prefixes, sir. How it will reach to R3?
It will
first,
reach
sir?
like this.
Yes, sir. Instead of reaching R5, 60 for 60 prefixes, to reach R5, AD value is 200, no, sir. From R6 to R5,
Yes.
AD value is
R2 to
no, sir. R6 to R5.
R6 to R5. So there is IBGP
200,
neighbor.
no, sir. Yeah, 200 AD value.
Yes.
Instead of reaching there, 60 prefixes can reach R4, no, sir, with 20 AD value.
Yes. 20 AD value.
That time, that time this is the best route, no, sir. This should be a best route.
On R4?
Yes, sir.
Yes, on R4, but on R1, why best route is this one via R3 for both prefixes? I am talking on R1 only. That on R1, why R1 have installed both prefix 50 as well as 60 via router number 3? On the basis of which attribute it is selecting best path?
So for reaching R3 and R5, it is taking AD value. For reaching R1, it is considering other attribute, no, sir?
Yes,
origin code.
other attribute.
Yeah. Okay, sir.
So
Then-
which
then it's-
attribute, this is my question, brother, that which attribute router 1 is using for best path selection? Let's discuss about only 50 prefixes. So see, router 3 is also advertising 50 prefixes and router 4 is also advertising 50 prefixes. Both next hop is reachable. Then on the basis of which attribute router 1 will decide that which path is best for me. Getting my point? Is question clear to everyone? Is question clear, guys?
Yes, sir.
So actually router 1 is just will check all attribute one by one. First it will check next hop, then weight value, then local preference, self advertise, AS path. AS path is also same, origin code is also same, MAT value is also same. Then router are going to check which attribute after MAT? Metric. This is MAT. So MAT is, you can see, 0 from both sides, from their both neighbor. Then it is going to check what? External over internal. So both neighbor are internal. Then it is going to check IGP cost to reach next hop. So IGP cost to reach next hop is also same. If router 1 want to reach 3.3.3, IGP cost is 1. If router 1 want to reach 4.4.4, IGP cost is 1. Then it is going to check what? Lower neighbor router ID, and router 3 have lower router ID. That's why router 1 have, see, router 1 is receiving same prefixes from two neighbor, okay, and one neighbor have lower router ID, one neighbor have higher router ID. So which path will be the best? One
Oh,
minute.
yeah, R3, sir.
Yes. Okay. So R1, on R1, let's say I want to install all prefixes via router number 4, not via router number 3. So I have two options. Either I can do one thing, either I can add some weight value, that is second attribute. So you already know how to add weight value. How I will add weight value? Router BGP 100 and neighbor 4.4.4.4 and weight. So here I can set weight value, let's say 10 for this neighbor. So now all prefixes will become best via router number 4. Do so IP BGP. Now these prefixes is best via which router? Okay, you have to clear the process. Clear IP BGP star soft in and so IP BGP. Now you can see best is via router number 4. Now 4.4.4. Why? The reason is here you can see weight value is 10 from neighbor 4.4.4 and weight value is 0 from neighbor 3.3.3. Yes or no? So this is the first option which in last class we had already discussed this. I am going to remove this command. Router BGP 100 and say no neighbor 4.4.4.4 and wait value 10. I have removed this command. Again router 1 will install all prefixes via which router?
R3.
R3. Very good. So IP BGP you can see via R3. 50 prefix also and 60 also. Then we have discussed the second thing. Okay, if you will add wait value, then you have to add wait value on all routers manually. Let's say here I am going to add that command, router BGP 100 and neighbor 4.4.4.4 and wait value is 10. So I have manipulated the path here with the help of wait value, clear IP BGP star soft in. Okay, and so IP BGP. Here I have manipulated the path. Now best path is via router number 4 because of wait value. But what about router 2? On router number 2 still you can see. So IP BGP. Best path is via router number 3. So if you are adding wait value, then you have to add it manually on all routers. Okay. So this is not the correct way for the path manipulation in my scenario. In some scenario it is perfect. Let's say only I have these prefixes in my AS domain, but I have multiple prefixes on multiple routers. So I want to manipulate path on all routers. So here, instead of changing the wait value, what I can do, I can add LP value, local preference value, on router number 3, on router number 4, on any router, because these two routers are the point from where traffic is coming in my AS and from where traffic is exiting from my AS. So if I will set any local preference value on router number 3, that local preference value will be same for all neighbor, for router number 1 also and for router number 2 also. So you already know how to add local preference value with the help of route map. How I will add local preference value, guys? On router number 1, first of all, I am going to remove the command router BGP 100 and I am going to remove neighbor 4.4.4.4 and wait value is 10. I am going to say no to this command. Very simple. Again, it will install best path via router number 3. Clear IP BGP star soft in and so IP BGP. It have installed best via router number 3. Okay, so with the help of local preference, see how I can manipulate the path. Again, my scenario is same, and this time what I want, that whenever these user from these network or these network want to reach in AS500, exit point should be R4. So I am going to add some local preference value for all neighbor on router number 4. What I will do on router number 4, simply I will create one route map. In that route map I can call that route map with BGP neighbor. So router BGP route map, and name of route map is, let's say, LP local preference. Okay, and that's it. Then set local preference value. Local preference, whatever local preference value you want to set. Let's say I want to set 110. Exit router BGP 100, and I am going to call this route map with, let's say, all neighbor. Or if I will call this route map with all neighbor, then I have to run two commands, one for router number 1, one for router number 2. So instead of adding local preference value with these neighbor, I am going to add local preference value with this neighbor. That whenever you will receive any prefixes from 6.6.6, you will add some local preference value. Getting my point? So I am going to say neighbor, and who is neighbor? 46.1.1.46.1.1.6 and route map. Name of route map is LP, and in which direction? Whenever you will receive any prefixes from this neighbor, you will add a local preference value which is defined in the route map. So in direction will be what? In. That's it. And here I am going to clear IP BGP star soft in. clear IP BGP star soft in. Okay, and now on router number 1, if you will check BGP table, so IP BGP, you can see local preference value is what? 110, 110, 110, 110. Now very important question is, now why router 1 is not receiving these prefixes from from their other neighbor 3.3.3?
R3. Yes, sir.
Yes, why router 1 is not receiving any prefixes from 3.3.3? You know the reason? See, when router 5 will advertise 50 prefix and 60 prefix to router number 3, local preference value will be what? 0. And same prefix when router 4 will advertise to R3, local preference value will be what? 110. Yes or no?
10.
So router
Yes, sir.
3, even router 3 will also learn these prefixes via router number 4 now in this scenario. Yes or no? So this is the
Okay.
complete on all routers. Actually we have manipulated the path. On router number 3 also, if you will check BGP table, so IP BGP, so you can see it is receiving this 50 prefix from which router? 4.4.4. It is receiving from 35.1.1.5 also, but that is now not best. Why? Because here you can see local preference value is what? 0, and from router number 4 local preference value is what? 110. Getting my point? Is it clear to everyone?
Yes, sir.
So this
Right.
is the second way through how I can manipulate the path. I am going to remove the command from router number 4, router BGP 100, and say no to this command. Neighbor 46.1.1.6 route map LP direction in. I have removed the command. Let me remove route map also. Say no route map LP. Done. Now the third attribute that we are using for path manipulation is ES path. That is ES path. Getting my point? Let's say I want to receive 50 and 60 prefixes again on router number 1 via router number 4. So by default, when both router is advertising, right, it is advertising with what? ES path 500. So if I will add some ES path over here on router number 3, right, then which path will become best? Automatically via router number 4, because least ES number is more preferable. So on router number 3, what I can do? I can add ES number. Again, I am going to create route map on router number 3. I will create one route map. Route map. Name of route map is, let's say, ES path. This is just name, and here in this route map I am going to say set. What you want to set? ES path, and then you will use one keyword, that is prepend, and whatever ES number you want to add here you can define. Let's say I want to add 999, 999 one more time, 999 one more time, or 110 one more. This is, so I have add actually 4 number of ES, and I am going to call this route map with neighbor. Which neighbor? I'm going to call this route map. Even if you will call this route map with neighbor router 1, then you have to run 2 command, right, for router number 2. Let's say if you have 100 number of routers here, then you have to run 100 number of command. So instead of applying this route map with this neighbor, you can apply this route map with this neighbor. That whenever you will receive any prefixes from router 5, you will add these what? ES path. So router BGP 100, and I am going to say neighbor 35.1.1.5 and use route map. What was the name of route map? AS under AS S path. Okay, and in which direction? Can anyone tell me what will be the direction over here? In or out?
In, sir.
In. Very good. And clear IP BGP star soft in. And on router number 1, so IP BGP. Clear IP BGP star soft in. And so IP BGP. Best path is via which router? Router
R4.
number 4. And why we are not able to see the prefixes via router number 3? Because router 3 even learned these prefixes via router number 4. Getting my point? See, in the on router number 3, if you will check BGP table, so IP BGP, when this router is receiving 50 prefixes from 4.4.4, it is receiving with what AS number, with what AS path? 500 only. But when it is receiving from 35.1.1.5, what is the AS path there? 999999999 110 and 500. We have added these AS path, and this is the AS number that router 5 is including in update. Getting my point? So even router 3 have also learned these prefixes via router number 4. Done. So this is also one way for path manipulation, but I must tell you that we are using like attributes like weight value or local preference for outgoing traffic, for the traffic which will exit from my ES. Let's say with the help of local preference value, I have installed this and this prefixes, these prefixes via router number 4. So now whenever any user from this network, let's say here is one user whose IP address is 10.1.1.1, will ping 60.1.1.1, router 1 will check the routing table, it will forward towards router 4, and router 4 will forward towards router 6. Yes or no? So actually we have manipulated the path for which type of traffic? For the traffic which is exiting from my ES. But the ES path attribute we are using for outbound traffic, for inbound traffic, for the traffic which will enter in my ES, not for the traffic which is going out from my ES. So this is ES path is used for inbound traffic manipulation, and weight value and local preference, these are used for outbound traffic. Done. On router number 3, I am going to remove the command router BGP 100 and say no to this command, and I am going to remove route map also. Say no route map. And what was the name of route map? ES path. Yes, ES path. That's it. Is it clear? Now let's understand path manipulation with the help of MAT value. MAT is also used for inbound traffic, not for outbound traffic. This is for inbound influence. For inbound traffic influence. So let's say I want whenever traffic will enter in my ES, it should enter via router number 4. Getting my point? What I am saying? Whenever, let's say here is one user, whenever this user will ping, let's say 60.1.1.1.1, okay, doesn't matter from where my traffic is going in ES 500, it is going via router number 3. But what I want, whenever traffic will enter in my ES, it should enter via router number 4. So this is what? This is inbound traffic influence. Okay, and we are using MAD attribute for inbound traffic influence. Okay, getting my point, guys? So what I want, that all the traffic which will enter in my AS, that should be entered via router number 4. So what I can do, whenever I will advertise prefixes, see, router 5 and router 6 will have this network and this network, yes or no? This network and this network, it will check their routing table. Like router 6 will have 10 network and 20 network. So IP route BGP, 10 is also there and 20 is also there, and reachable via 46.1.1.4. It will forward traffic to which router? Router 4. And for 10 network, it will forward traffic to again router 4. Getting my point? But on router number 5 also, let me check R5. So IP route BGP. When this router will ping 10.1. It will forward traffic in this network, 10 network. It will forward traffic to R3, and when it will forward traffic to R20 network, also it will forward traffic to R3. Means router 6 is advertising prefixes via it is forwarding the traffic. See guys, traffic forwarding is inverse to prefix advertising, right? Like if router 6 is getting prefixes, 20 prefixes via router number 4, then it will forward any traffic in 20 network via router number 4. Yes or no? 1 minute. Forward traffic to router number 4. For 10 network and 20 network, let's say if router 5 need to forward any traffic in this network 10.1.1.0 to 10.1.5.0, it should forward to router 5, and then it should forward to router 4, and router 4 should forward to router 1, like this. This should my traffic flow. But now router 1 is forwarding to router number 3. And let's say you are, this is your organization and you don't have access of router 5 and router 6. These are ISP. So you are not allowed to configure anything on router number 5 on router number 6. Then how you will manipulate the path? With the help of MAT value. What I will do, whenever R3 will advertise any prefixes, it will advertise with some metric, let's say 100. Whenever router 4 will advertise some prefixes, it will advertise with metric what, 0. So router 6 will also advertise these prefixes to router number 5 with metric 0. Now let's see, router 5 is getting same prefixes from their eBGP neighbor also, and from their iBGP neighbor also. But MAT value, metric is different, right? So it is not going to check external over internal attribute. Before external over internal, it is going to check what? MAT value. Getting my point? So I am going to change MAT value on router number 3. Okay. So what I will do to change MAT value, in my ASC, I am configuring in my AS router, right? My organization's router, and I am manipulating the path. On router number 3, I will create again one route map, and let's say name of route map is MAD. MAD means metric. Done. In this route map, I am going to set some metric value this time. Set metric. And what metric you want to set? Let's say I want to set 10. That's it. Done. Now go to router BGP 100 and say neighbor. Who is neighbor? 35.1.1.5. Call to route map whose name is MAD, and this time tell me what will be the direction. What should be the direction? Yes, Nirav. What should be the direction? See, actually I want to tell to router 3 that whenever you will advertise any prefixes of AS100 to router number 5, you should add this MAT value.
Then it should be out, sir.
Yes, we always apply MAT value in out direction. You can apply it in direction also, but I am telling you the scenario of real time. In real time, we are using mat value in odd direction only. Reason is we are using mat value for inbound traffic influence, not outbound traffic influence. So let's say direction out. Okay, done guys. And on router number 5, now I am going to check again next hop for 10 and 20 prefix. Clear IP BGP star SOP in, and so IP route BGP. Now you can see it have still this is 35.1.1.0. What happens? So IP BGP. Here metric is 10 and here metric is 0. Then why this network is best? Why this network is best? Lower metric is best or higher metric is best? Lower metric is best because this next hop address is not reachable. Getting my point? So just I need to tell to router 6 that next hop cell for neighbor 56.1.1.6. Okay, now if you will trace route, let's say on router number 1 I'm going to trace route 60.1.1.1 and source is 10.1.1.1 numeric. Traffic is going to router 4 and then router 4 is forwarding to router number 6, and for 50 prefixes router again it is forwarding to router 4 and router 4 is forwarding to router 4 is forwarding to 56 dot router 4 46.1.1.6 is the hop. 46.1.1.6 is the next hop. Before that, okay, this one, yes, it is going via router number 3, then router 6, then router number 5. Yes or no? So just I need to do one thing. On router number 6, I am going to say to this router, because this is border router BGP 500 and neighbor 56.1.1.5 next hop self. This command will be automatically enabled on all edge router. Like on router number 5, now I am going to check clear IP BGP star SOP in, and so IP BGP. So now you can see 10 network is best via which router? 56.1.1.6, because from one side it is getting matrix 0 and from one side it is getting matrix 10. Is it clear? Is it clear, guys? Now from here, router number 5, if I will forward any traffic to 10.1.1.1 and source is 50.1.1.1 numeric. So you can see traffic is going to 56.1.1.6 means router 6, then to router 4 and then to router 1. But if you will remove the MAT value from router number 3, then it will forward traffic via router number 3. I am going to say no to this command. just no to this command. And on router number 1 I am going to clear IP BGP star soft in, and again I am going to trace route the same network. This time you can see it is forwarding traffic to 35.1.1.3, then router 1, router 3, router 1. Okay, so when you want to influence inbound traffic, then you will use this attribute, that is MAD attribute. Now I have removed the command. I'm going to remove route map as well. No route map, MAD. Fine. So is it clear? Like on, I want that whenever any user from outside will enter in my AS, it should enter via router number 3. Then what I can do, I can add MAD value on router number 4. In the same way, I will create one route map on router number 4, and I will apply that route map with neighbor 6, router 6. Route map, MAD, and set metric value. Let's say here I am going to set 5, and router BGP 100 and neighbor 46.1.1.6 and route map MAD direction out. That's it. Now on router number 5 or on router number 6, on any router, if you will trace route, you can see traffic is going via router number 3, right? On router number 6 also, but before that here I have to run one more command, router BGP 500 and neighbor 56.1.1.6 next hop self. Okay, so on router number 6 also you can see, if I will trace route, clear IP BGP star soft in, and now if I will trace route 10.1.1.1 and source is 60.1.1.1 numeric, now you can see traffic is going to router number 5, then traffic is going to router number 3. So all traffic will come in my AS via router number 3. And let's say I want that all traffic should go from, means all traffic should exit from my AS via router number 3. Means traffic should enter in my AS via router number 3, but traffic should exit via router number 4. This is what? Asymmetric routing. Getting my point? So what I can do? What I can do, guys? Now both router, see, router 5 and router 6 is forwarding traffic in 10 network and 20 network via router number 3, and router 1 and router 2 is also forwarding traffic in 50 and 60 via router number 3. But my concern is I want to exit all traffic from my AS via router number 4, and I want to receive all traffic in my AS via router number 3. So for these prefixes, what I can do, I can add local preference value on router number 4. I can add AS path, any other attribute I can use in indirection. Getting my point, guys? Let's say on router number 3, if I will create one more route map and LP, name is LP, and here I am going to say set MAD or metric 10, okay, exit, and I am going to call this route map in, let's say, in indirection. For indirection, I am going to call this route map, that whenever router 5 will advertise any prefixes, you will add this MAD value. So automatically on router number 2 and router number 3, best path will become via router number 4, because router 3 will advertise with metric what? 10. Getting my point? So router BGP 100 and say neighbor 35.1.1.5, use route map. Name of route map was LP. So LP and direction. In which direction I will apply it? See, I am, performing, I want path influencing for outbound traffic. So I will apply it in direction, that whenever you will receive prefixes, then you will add matrix 10. So in direction. Okay. And here I am going to say clear IP BGP star soft in. Now you can see on router number 1. When router 1 will forward any traffic, so IP route BGP to 50 network and 60 network, it will forward via which router? Via router number 4, yes or no? In the same way, router 2 will also forward all traffic via which router? So IP route BGP via router number 4, via router number 4, 460 also and 450 also, because so IP BGP, when it is receiving 50 prefixes from this neighbor, when router 3 will advertise it, even actually router 3 is also not receiving it, so that's why you are not able to see both path in the BGP table, because router 3 will also learn 50 and 60 via router number 3, but I have manipulated the path. Whenever router 1 on router number 2 want to reach in 50 and 60 network, it will reach via router number 4, but whenever router number 5 and router number 6 want to reach in 10 and 20 network, so IP route BGP, it will reach via which router? Via router number 3. And in the same way you can check router 6 also, so IP route BGP 10 and 20 is reachable via router number 5. That means in my AS traffic will enter via router number 1. So now actually this is R3 is my entry point and R4 is my exit point. Getting my point? Is it clear? Is it clear? Is it clear, guys? Nirav, Suresh, Mohan, is it clear? Next attribute is external over internal, so we don't need to perform any practical for external over internal attribute. Till here is, if everything is okay, please let me know.
Yes, sir.
Okay, everything is clear to everyone. Now what topic is left in BGP? Do you guys want to learn advanced BGP or advanced path manipulation? First, try to understand how many way we have to advertise prefixes in BGP. Let's discuss this today. So I am going to open GNS, or I am going to, okay, keep this lab here. Let's say I have one router here, one router is here. I am only, let's say, two router, both are directly connected, and router 1 have some network. Router 1, between router 1 and router 2 I will use 12 network, as you know, as I always use, and router 1 have some network, let's say 192.168.10.0/24 to 192.168. What we can say, 50.0/24. Okay, and you want to advertise these network in BGP. So see how many way we have to advertise these prefixes in BGP. Guys, whenever we are advertising any prefix in BGP, so make sure first of all that prefix should be available in the BGP table with same prefix length. Let's say I have one network 192.168.10.0/24, okay, in the routing table, and if I will advertise this network in BGP table like network 192.168.10.0 and subnet mask 255.255.255.128, so now prefix length is different, yes or no? So we cannot advertise the network which is not available in routing table with same prefix length. Okay, so on router number 1, first let me configure the scenario. Interface F0/0 no shut and IP address 12.1.1.1 255.255.255.0. Exit interface loopback 1, IP address is 0 255.255.255.0. interface loopback 2, IP address is 10.1.2.20.0. loopback 3 10.1.30.0 let's say, and 10 loopback 4 10.1.40.0. It's okay 50.0 loopback 5 50.0. So I have created the loopback interfaces here. So IP interface brief exclude unassign. Where is loopback interface, guys? What happened here? So run interface loopback 1. Oh, so history config t interface loopback 1, IP address is 192.168.10.0/20.1. Oh, I was advertising network. This is just a small concept of BGP. So IP interface brief exclude unassign. Okay, so IP configuration is done here. I'm going to configure BGP also. Router BGP, let's say 100, and neighbor is 12.1.1.2. remote AS is, let's say, also 100. Okay, this is not my concern, iBGP or eBGP. Interface F0/0 no set IP address 12.1.1.2 255.255.255.0. done. Router BGP 100 and neighbor 12.1.1.1 and remote AS of neighbor is 100. Soon neighborship will come up. Okay, now I am going to advertise the loopback interfaces in BGP. Okay, so see, first command is network 192.168.10.0. Can I run command like this without specifying the subnet mask? Anyone? Hello? Are you there, Mohan? Suresh? Are you guys there?
Yes, sir. Yes, sir.
Yes, so if I will run command like this, will it work? Yes, it will work because I am advertising class full network. Okay, so if I will run command like this and do so IP BGP, you can see router have installed this network in BGP table. So you can ignore subnet mask in case of class full network. I'm going to say no to this network command. Okay, first option is through network command, and if my network is class full, then I can ignore subnet mask as well. But if I will advertise network, let's say here I have one more loopback. I'm going to create one more loopback here, interface loopback, let's say 10, and IP address is 10.1.1.1 Okay, so I have created one more loopback here, that is 10.1.1.0/24. Fine. On router number one, if I will run network, sorry, router BGP 100 and network 10.1.0.0.0 or 10.1.1.0, this command, will it work if I will advertise this command like this network by this command? It will not
No,
work,
sir.
guys.
No,
See
yes, sir.
why it will not work. So IP BGP, in BGP table you can see there is no any network, because automatic summarization is enabled by default in BGP. Getting my point? What I am saying, by default automatic summarization is enabled in BGP. This is the reason why you are not able to advertise this network by using this command. Okay, auto summary. So if I will run this command, then so IP BGP, still I don't have anything. So it will not work. It will not work. And if I will disable automatic summarization from here and so IP BGP, still you can see do, now it should work, I think. So IP interface brief. So loopback 1 is there, 10.1.1 is there. Okay, so network 10.0.0.0 do so IP BGP and auto summary and do so IP BGP. Okay, so if automatic summarization is enabled by default, sorry guys, by default automatic summarization is disabled. By mistaken, I think I have said it is enabled. By default automatic summarization is disabled. If automatic summarization is enabled, then you can run command like this also, because this network is not available in routing table with prefix length what, 8, but still you can see in BGP table it have installed the prefix. Okay, okay guys, then say no network, this one, and do so IP BGP. Now you can see I don't have any prefixes. The third option is, second option is, you can enable automatic summarization and you can run, but it will, BGP will advertise the prefixes, class full prefixes, not classless prefixes. If you will run command like this, it's not depends on your routing table how prefixes are available in routing table, because you have enabled the automatic summarization. The third option is redistribute. We can say redistribute connected. It will advertise all connected network in BGP. Okay, so if I will run this command and do so IP BGP, you can see it have installed all prefixes. But how it have installed 10.1.1.0/24 network like a class full network? Yes or no? Is it okay? And after that 12 network is also advertised in BGP, and these are the loopback. So this is third option to advertise prefixes in BGP. We can say redistribute connected. I'm going to say no to this also. And again, show IP BGP, you can see don't have anything in BGP. And let's say I want to advertise a particular loopback in BGP. I want to advertise a particular loopback in BGP by redistribution. So we cannot run redistribute connected command, because if you will run redistribute connected command, then it will advertise all connected network. Like here you can see it have advertised 12 also, WAN link also. But generally we never advertise WAN link in BGP. Yes or no? So we will not use this command, redistribute connected. Then what is the third option? Third option is, guys, again route map. Route map, and then name of route map is, let's say, loopback 2. I want to advertise only loopback 2 in BGP, and I am going to say permit. So I have created the route map. In this route map, I am going to match loopback interface. Whatever interface you want to match here, you can match, like match interface loopback 1. So I have matched this interface, loopback 1 interface, and now I am going to call this route map while redistribution. Router BGP 100, router BGP 100, and redistribute connected and not all connected route map, and name of route map loopback 2. This was the name of route map. Yes. Now do so IP BGP. I don't have any prefix. Loop back. There is misconfiguration here. Name is wrong. So say no to this, because route map name is wrong, guys. Here loopback 1O is missing there. Okay, and do so IP BGP. Now you can see in BGP. Fine. So this is the best way to advertise prefixes in BGP, yes or no? Because if I will run network command, then if there are 100 prefixes, then I need to run 100 times network command. If I will run redistribute connected, then my WAN link will also advertise in BGP. Or let's say I don't want to advertise some prefixes in BGP. Like there is one loopback 1.1.1. I am using that loopback just to create BGP neighborship. So if I will run redistribute connected command, then all connected interface will advertise in BGP. That is not good. So that's why we have the third option, that is route map. Through route map, first I will create the route map. In the route map, I will match the interfaces, whatever interface you want to advertise, and then I will call route map while redistribution. Fine. Is it clear?
Yes, sir.
One more thing here, I think I am missing route map, let's say CCNA, and I'm going to say here, I'm going to say match interface, and then I have lots of option, right? So is there any So you can use command like this. Whatever interfaces you want to add in the route map, you can add. Okay, say no route map CCNA. Okay, is it clear? Now in BGP we have advanced path manipulation only. Okay, we had discussed basic things, we had discussed attribute, we had discussed directly connected neighborship, indirectly connected neighborship. Okay, we have discussed path manipulation also, but we had not discussed advanced path manipulation. And there are some advanced concepts, guys, that is really very advanced concept. So I don't think that we should discuss those things now. So now we should move to switching module. So are you guys ready? Or if you want to learn advanced concept also, please let me know. I don't have any problem. Advanced concept of BGP. By the way, I have already uploaded those video on YouTube as well, like community attribute. Okay, there are some external attribute, optional attribute. So video is already available. Videos are available on YouTube. Here I think we should now move to switching module, because we have expended lots of time in routing module. Now hope your routing is somehow strong.
Sir,
Yes.
there is no MPLS and VRF.
VRF also you want to learn here? Okay. So we can do one thing. After switching module, we can start MPLS and VRF. Okay.
Okay, done.
MPLS and VRF we will start after switching module. First, let's finish the syllabus. Okay. Any doubt? Any
Okay, okay, sir.
confusion? Any
We can move.
question? We can move now? Yes, yes.
Yes, sir. Yeah.
I also think that now you should move to switching module. First, you should learn some basic concept and advanced concepts of switching also. Like there are STP and long lengthy topics are there. Hmm.